In this video, we are going to solve problems under Laplace transformations. The Laplace transformations of any function, say f of t, can be represented by L f of t. That is, if the function is also in terms of x, let's say f of x, then the Laplace transformation for this function f of x can be represented like this: f of x. Okay. So now let's work some few problems using the standard list of Laplace transforms. Evaluate the following. So before we solve this problem, we need to know some few formulas. We need to know some formulas that we use to work this out. So the Laplace transform of any constant, let's say k, is going to give us k out of s. For instance, if we have to find the Laplace transform of 2, it's simply going to be 2 out of s. So the Laplace transform of minus 3 is going to give us minus 3 out of s. Laplace transform of 100, so given to us, and 0 out of s. Laplace transform of 5 is going to give us 5 out of s. So generally, Laplace transform of any constant is going to give us, that constant out of s. So let's continue. So first formula, Laplace transform of any constant is going to give us that constant over s. The second formula you need to know is Laplace transform of any function of the form t to the power n is going to give us n factorial over s to the power n plus 1. So assuming we have x to the power 2, so Laplace transform of x to the power 2 is going to give us, in this case, our n is 2, so 2 factorial all out of s to the power 2 plus 1, which is going to give us 2 out of s to the power 3. So that's the second formula you need to know. Let's continue. So the third formula you also need to know is the Laplace transform of e to the power 80. So e to the power 80 is going to give us 1 out of s minus a. So assuming we have to find the Laplace transform of e to the power 2x. In this case, let's say our function is in terms of x. So our a is 2 now. Our a is the coefficient of x, which is also going to give us 1 out of s minus our a. In this case, our a is 2, so minus 2. So find the Laplace transform of e to the power negative x. So in this case, our a is minus 1. We are going to get 1 out of s minus 1, which is going to give us 1 out of s plus 1. So back to the problem. The Laplace transform of t to the power 2, Laplace transform of t to the power 2 is going to give us what? In this case, our n is 2. So our n is 2. So the Laplace transform of any function of the form t to the power n equal n factorial or out of s to the power n plus 1. Since our n is 2, then this will give us 2 factorial or out of s power 2 plus 1. You can put 2 factorial on your calculator. You can also calculate it manually. So 2 factorial is simply, let's say, 2 by 1. So 3 factorial is going to give us 3 by 2 by 1. 4 factorial is going to give us 4 by 3 by 2 by 1. So let's simplify this. This is simply 2 by 1 out of s power 3. And 2 by 1 will give us 2. So our final answer for this is 2 out of s power 3. What about number 2? The Laplace transform for 5t power 2 plus 4t. So for a coefficient, we just leave it as it is and find the Laplace transform of the other thing and multiply it by the coefficient. So we are simply going to write 5. Laplace transform of t is going to give us 2 factorial out of s power 2 plus 1. Then you bring our plus 4 into bracket. What's the Laplace transform for t? T is to the power 1. So our n here is 1. So 1 out of s to the power n plus 1. Our n is 1 plus 1. So let's simplify this. 5 into bracket 2 factorial is the same as 2 s to the power 3 plus 4 1 factorial is the same as 1. So 1 over s to the power 2. So let's simplify this further. 5 by 2 to the power s, 2 over s to the power s3, 2 over s to the power 3 will simply give us 10 out of s to the power 3 plus 4 out of s to the power 2. So this is our final answer for this. Now find the Laplace transform of 2t minus 3. So we just bring our 2. Laplace transform for t, our n here is 1. So 1 factorial, which is 1 out of s to the power n plus 1, giving us 2. So Laplace transform for any constant is the same as that constant out of s. So we are going to get our final answer to be 2 out of s to the power 2 minus 3 out of s. So you can go ahead and simplify this. You can also decide to leave it that way. Simplifying this, 2 by s, we just cross multiply. So 2 by s giving us 2s minus s square by minus 3, giving us minus 3s square, all out of s square by s, giving us s to the power 3. So this is our final answer. Find the Laplace transform of 5e to the power 3t. So now we know coefficients are not to be affected. So just leave our 5 into brackets. Laplace transform of e to the power 3t. Laplace transform of e to the power 80 gives us 1 out of s minus a. In this case, our a is 3. So our a is 3. Our a here is 3. So just 1 out of s minus 3. So simplifying this will give us 5 out of s minus 3. Let's go a little bit harder. Find the Laplace transform of this function. This function. So this symbol earlier indicate that you should find the Laplace transform of this. So let's start. The Laplace transform of a constant is that constant out of s. So 1 over x. So coefficient, you just leave it. So Laplace transform of t gives us what? 1 factorial out of s to the power 1 plus 1, which is 2. So we leave this here. This is also a coefficient, so minus 1 out of 3. So Laplace transform of t to the power 4 is going to give us 4 factorial or out of s to the power n plus 1, and our n here is 4. So 4 plus 1 giving us 5. So let's simplify it further. So 1 factorial is the same as 1. So we are going to get 1 out of s plus 2 out of s squared minus 1 out of 3. 4 factorial is going to give us 24. So it's 4 by 3 by 2. So 24 out of s to the power 5. So let's simplify this. So 1 out of 3 by 24 is going to give us 8, and it's a minus. So we have 1 out of s plus 2 out of s squared minus 8 out of s to the power 5. So we are done for this. So find the Laplace transform for this. So let's go. You know 5 is a coefficient, so you just leave it like that. So multiplying e to the power 2t. In this case, a is 2. So we are going to get 1 out of s minus a. So s minus a, and our a is 2. So minus 3 e to the power minus t. 3 is a coefficient, you just write it. So e to the power minus t, in this case, our a is minus 1. So 1 out of s minus minus 1. So simplifying this, we are going to get 5 out of s minus 2 and minus 3 out of s minus minus 1 is going to give us s plus 1. so s plus 1. It is preferable for us to simplify our answer, to simplify this further. So to simplify this, let's cross multiply and divide everything by the product of the denominators. So 5 by s plus 1, minus 3 by s minus 2, s minus 2. So give us the product of the denominators. So s minus 2, s plus 1. So let's simplify the top. So 5 by s will give us 5s, 5 by 1 will give us just 5. Minus 3 by s will give us minus 3s, minus 3 by minus 2 will give us positive 6. All out of s minus 2, s plus 1. So to simplify this further, we have 5s here and minus 3s here. So we are going to get 2s. And then 5 plus 6 will give us 11. So plus 11 all out of, s minus 2, s plus 1. And mostly, we also have to simplify our denominator. So we just have to simplify everything, both the top and the bottom. So let's do that. Simplifying our denominator, we know that s by s equals to give us s squared, s by 1 giving us s. So minus 2 by s giving us minus 2s, and minus 2 by 1 giving us minus 2. To go further, we're going to get s squared, s minus 2s giving us minus s, and our minus 2. So now our final answers will be 2s plus 11, all out of s squared minus s minus 2. So s squared minus s minus 2. So that's it. Find the Laplace transform of this. So now you will see that we have a fraction here. Let's say if we have something like x out of 2 is the same as writing it 1 out of 2 multiplying by x. So let's go ahead and simplify this. So t to the power 3 out of 24 can also be written as 1 out of 24 multiplying by t to the power 3. Yes. So what we're going to do is that let's find the Laplace transform for t to the power 3. Straightforward. So t to the power 3, here our n is what? 3. And it's going to give our 3 factorial. Sorry, let me cancel this. So simply, we are going to get 1 out of 24 multiplying 3 factorial out of s to the power n plus 1, which is 4. Minus 3, 3 here is a coefficient, so just write it. T to the power 1. So 1 factorial out of s to the power n plus 1, and our n here is 1, so 2. And Laplace transform for any constant is the same as that constant out of s. So now let's simplify this further. So 3 factorial is same as 3 by 2, which will give us 6. So we are going to get 1 out of 24 multiplying 6 out of s to the power 4. So 1 factorial is same as 1. So by 3, we get minus 3 out of s to the power 2 plus 2 out of s. So we can simplify this 6. Let's simplify 1 out of 24 multiplying by 6 out of s to the power 4. 2 here, 1, 2, 2 here, 3. 3 here, 1, 3 here, 4. So this is simply going to be 1 out of 4 multiplying 1 out of s to the power 4 minus 3 over s power 2 plus 2 out of s. So this is going to give us 1 out of 4 s to the power 4 minus 3 out of s squared plus 2 out of s. So that's it for this question. Let's work this as our final problem on this. Then we'll move to another aspect. So we have to find the Laplace transform of this. So this can be written as 1 out of 15 into bracket. Then we find the Laplace transform of t to the power 5. In this case, our n is 5, so 5 factorial out of s raised to the power n plus 1. So 5 plus 1 giving us 6. So this is a coefficient, so just 2. T to the power 4, n here is 4, so 4 factorial out of s to the power n plus 1 giving us 5. And plus this one is 1 out of 2, 1 over 2 into bracket. N here is 2, so 2 factorial out of s to the power n plus 1 giving us 3. So let's simplify this further. 5 factorial is going to give us 20. So 1 out of 15 multiplied by 20 out of s to the power 6. So 4 factorial will give us 24. So minus 2 to 4 over s to the power 5. And 2 factorial will simply give us 2. So plus 1 over 2 multiplying 2 out of s to the power 3. So let's go. So you can see that from here, 5 goes here 3, 5 goes here 4. Sorry, 5 factorial should give us 120. 5 factorial should give us 120. So 120 out of 15. So if we cross cancel this, we're going to get 8 out of s power 6. Then minus 2 multiplied by 2, 4 out of s to the power 5. 2 by 2 give us 4. 2 by 4 giving us 8 over s to the power 5. So plus our 2 here, we just cancel 2 here. So 1 out of s to the power 3. So that's it for this problem. How can we find the Laplace transform for this? Before we do this, we need to know some formulas. Let's go. The Laplace transform of a function of the form cos at is going to give us s over s squared plus a squared. The Laplace transform for any function of the form, let's say the function of the form cos h at is going to give us s over s squared, in this case minus a squared. You have to know these formulas by heart before you'll be able to solve questions under Laplace transform like this. So the Laplace transform of sine at to give us a over s squared plus a squared. And the Laplace transform for s h a t to give us a over s squared, in this case minus a squared. I personally arrange these formulas in order for it to be easy to record them. Now that we know these formulas, we can go ahead and work some examples. So we have to find the Laplace transform of cos 2x. And we know that Laplace transform for any function like this, like cos at, is going to give us s over s squared plus a squared. In this case, our a is 2. So our a is 2. Therefore, the Laplace transform for cos 2x is going to give us our a is 2. So just s over s squared plus a squared, and a is 2, so 2 squared gives us 4. Find the Laplace transform for sine h 20x. How do we solve this? And we know that a Laplace transform for sine h ax or 80, in this problem we are using t. I mean, our function is in terms of t, so it can be x, it can be any variable. So will be equal to a over s squared plus minus a squared. Since it's in h, the denominator is minus. If it were to be normal sign, then s squared plus a squared. So in this case, comparing this to our problem, we will see that our a here is 20. So Laplace transform for sine h 20x is simply going to be 20 over s square minus a square. 20 square is going to give us 400. So that's it for this problem. Find the Laplace transform of 5 sine 5x. So you know that Laplace transform of sine 5x is going to give us, in this case, a is 5. So it's going to give us which is 5 over x square plus a square, which is 5 square, giving us. So simplifying this will give us 5 over x square plus 25. That's it. Find the Laplace transform for cos h7t. So this is simply going to be Laplace transform for cos h7t. In this case, our a is 7. So cos gives us s over s square is cos h70 h. So minus uh, our a square, which is 7 square. So simplifying this will give us s over s square minus 49. Find the Laplace transform of this. So this is a coefficient. So we just leave it. Let's say Laplace transform for this. So we just leave the coefficient. And then Laplace transform for sine 3t is what? So into bracket sine 3t. Sine is a over s square plus a square. So Laplace transform for sine 3t give us a. In this case, our a is 3. So 3 over s square plus a square, which is 3 square. So we are going to get 3 over s square plus 9. 3 square will give us 9. So let's simplify it. So 3 by 6 will give us 18, right? 3 by 6 will give us 18 over s square plus 9. So this is our final answer. Find the Laplace transform for this. So 6 is a coefficient. So we just leave 6 into bracket sine 3t. Sine is a over s square plus a square. So our e is 3 over s square plus a square, which is 3 square, minus 4 into bracket cos 5t. Cos is s over s square plus a square. So s over s square plus a square. In this case, a is 5. So 5 squared. This is s. So let's go. 6 by 3 will give us 18, right? 18 over s square plus 3 square will give us 9. So 4 by 5 will give us 20 all over s square, and 5 square will give us 25. So that's it for this problem. Find the Laplace transform for 7 cos h 2x. How would you do this? So how do we solve this problem? Sorry, trying to put this into bracket. So 7 is a coefficient, so just leave 7. Cos 2x is going to give us s over s square minus a square, and our a in this case is 2. So 2 square gives us 4. So simplifying further, our final answer is going to be 7s over s square minus 4. How do we solve this? How do we solve this? We have 1 out of 3 sine h 3t. So 1 over 3 is just a coefficient, so 1 out of 3. So into bracket sine h 3t. Sine h is a over s square minus a square. In this case, our a is 3. So 3 over s squared minus a squared, which is 3 squared. So simplifying this, we are going to get 1 out of 3 multiplying 3 over s squared minus 9. So at the end of the day, 3 here will take care of this 3, and we are going to get 1 over s squared minus 9. So that's it for this problem. Find the Laplace transform for 2 cos h 2 theta minus sine h 3 theta. How do we solve this problem? We see that we have 2 here as a coefficient. So let's bring 2 out into bracket. Cos h 2 theta, in this case our h is 2, our a is 2. So s over s squared minus a squared, which is 2 squared, minus sine h 3 theta, give us a out of s squared minus a squared. So this is going to give us our a here is 3, so a 3 over s squared minus 3 squared. So let's further simplify it. So 2 multiplying this will give us 2s over s squared minus 4 minus 3 over s squared minus 9. So our final answer is 2s over s squared minus 4 minus 3 over s squared minus 9. So that is for this problem.
Notice that s is assumed to be a real number and it is greater than 0. Check my video on inverse of Laplace transform shift theorem, and don't forget to subscribe and like my video. Thank you.